you are all good, we can start for sure.
Yeah, thank you, Praveen. Hope the participants have come back. I once again welcome you all to the gathering. Now I request Dr. G. Kalyani, Controller of Examination of Adisangara DB University, to introduce the chief guest to the gathering. Ma'am, please, ma'am.
Thank you. I'm very much pleased to introduce our esteemed guest, Praveenkumar Pugazendhi, who is a seasoned expert in CAD, PLM, and systems engineering with more than 18 years of experience across automotive and aerospace domains. He currently leads digital product development initiatives in electrical vehicle space, driving innovation through data-centric approaches using platforms like 3D experience. His focus areas include sustainable product architecture, engineering change management, system integration, and traceability across the product lifecycle. He is more passionate about enabling cleaner mobility and combining technology and system thinking to engineer sustainable and future-ready EVs. Mr. Praveenkumar is presently working as a senior manager, product configurations and advanced solution Lucid Motors. Now, I would like to invite our guest to take over the session. Thank you, sir.
Thank you, Kalyani, for warm welcome. It's definitely a pleasure to meet you all, and I would like thank you, Dr. Manoj, for this wonderful opportunity. He's very good friend of mine during my college days, and thank you, Manoj, for this. Okay, for sure. Before jumping into this session, I would like to ask you, how many of you know what is Lucid Motor or heard Lucid Motors? Maybe you can give a thumbs up, or in the chat bot you can put your comments, please. Do you guys know Lucid Motors? Anytime you heard Lucid Motors in the past? No worries. So I would like to take my journey along with the Lucid Motors, how we achieved the sustainability, or still achieving. It's not sustainability is not any end. Okay, sustainability along with systems thinking and using system engineering methodology. Okay, so again, good evening, everyone. I'm very excited to be here with all of you for this faculty development program. Thank you for joining today's session on this topic. So today we will explore two big ideas. Yes.
Sorry for interfering you. Yeah, message from our participants that they want to see you clearly. So the backlight behind you is interfering them. That's a request from them.
It's better now?
Yeah. Thank you, Praveen.
No worries. Sorry. Because it's sun here in my back, so probably the reflection.
Yeah, understood. You are in the morning time, the sun is rising. Yeah.
Yeah. Sure.
Thank you.
Sure.
Thank you.
Sorry for the chaos. Okay,
thank you. Please go ahead, Praveen.
Okay.
Please. Thank you.
So today as I said, today we'll explore two big ideas. One is sustainability in engineering, which is not just a buzzword, but how it really plays out in the practice. We're going to talk throughout this session, and also system thinking, which is a way of looking at the big picture so we can solve the complex problems like building a EVs or without getting lost anywhere. Okay. So definitely, I promise you at the end of the session, if you guys already not aware about what is systems thinking or model-based systems engineering, I will keep it very simple and very practical, and what we gone through in Lucid Motors as our journey. So it's mainly on sharing session rather than kind of I'm giving some research paper or something like that, because I'm more on tools and process and methods area. So I'm just sharing my experience with all of you about our journey. Okay. So now we talk about engineering and sustainability, correct? It is easy to think only in terms of components. If you take a EV, so we have like batteries or motors or softwares, but at the heart of engineering is about creating the customer experience. our fundamental goal as a Lucid Motors is how we can able to provide the exceptional experience to the customer. Okay, I'll give one analogy. Think about it. Okay, why people will buy the electric car? Anyone is aware? It is not just for zero emissions, correct? It also, especially in Bay Area or US, it is especially because they want to have the kind of exciting driving experience. It is not just giving something to the planet or whatever environmental constraints and all those things. At the same time, we have to give the the experience which they expect, correct? So the way today, if you see the IC engines, they give very kind of thrilled driving experience. There is a good amount of space, just compromising nothing. So that is our Lucid tagline. We will never compromise anything. At the same time, we have to provide the exceptional experience to the customer. So that is one of the key for Lucid Motors. Okay. So I would like to play a small video about. So before that, I will kind of give some sort of context. What is Lucid Motors and who we are? So I'll play a small video for all of you. If Manoj, let me know you can able to hear the sound because that very much matters for us. Okay.
Yeah.
Right. You can able to hear the sound?
Yeah, we can able to hear, but the volume is very
Yeah.
low.
Okay, let me increase it.
Hey, right now. This is as good as it
Now it's
gets.
fine.
This is one of the best sedans ever made. I'm not saying electric, it's one of the best sedans ever made.
I'd say it's one of the best driving cars I've ever had the pleasure of driving.
Now volume is not there.
You can able to. You are not able to hear the volume now.
Yeah. Now the volume we cannot able to get. So, are you working on the volume?
I think probably there might be the issue with the internet, Manoj. Probably you couldn't able to hear much volume.
Okay.
So
That's
it is
fine.
on and off, or how it is?
It's okay. The volume
It's
is
fine
not.
anyway.
Yeah.
It's more on the background music. It's fine. So I will explain it, or maybe in the next coming slides, definitely we are going to explain our journey and what we have done and what we are going to do in the future. Also, okay, no worries.
Yeah, thank you. Yeah, please go ahead.
Okay, so this is our key milestones, or I used to call it we used to call it a journey. Am I going too fast, Manoj, or it's okay? Or
It's
maybe I
okay,
need to
sir.
slow down. Okay, no worries. Okay, so every innovation, it's as a story timeline. As a Lucid Motors, we started in 2016, and we have started laying down our manufacturing facility, which we used to call as an advanced manufacturing plant. One in Arizona in 2017, and we have launched our first flagship product, Lucid Air, in 2021. The same time, we listed our company in NASDAQ, And in 2023, again, we started producing our product in our AMP2, which is in Saudi Arabia. And today, as we speak, our first SUV is out in the market, which is kind of sold across globe, primarily in US as well as Asian market. I mean, I would say it's on Middle East. Okay, so this is our journey timeline. So what exactly here is we will go deeper into how we approach these kind of challenges, and starting this technology is setting for us, because it is a brand new company. We started around 2016, and as we grow, the complexity also it is growing in terms of data management, in terms of design, in terms of a whole product development. Correct? There are a lot of complexity from a small team into a bigger. Today we have close to 5,000 employees, and we are working in 3 production products, as well as there are future products also it's coming. So the complexity is enormous. So next one is I would like to talk about the core technologies that drives sustainability in electric vehicles. Specifically, when people think EV, first things that usually comes into the mind is battery. Of course, the battery technology is central part of the EV, but it's not only the factor, correct? We need to have a good aerodynamics as a smooth, the car cuts to the air. And of course, the battery innovation, we need to have the energy dense battery. And of course, we need to meet the charging efficiency. And the next one is charging systems, because we need to have a fast charging, which needs to be accessible to everyone, every one of our customers. So why do this matters specifically for sustainability point of view is because every small efficiency here compounds the huge lifetime savings with respect to sustainability. Correct? For example, if I can talk about the aerodynamics, which may look in the design choice, but the simple fact is the improving the vehicle drag coefficient by 0.01% definitely adds 5 to 10 miles of range in the vehicle, which means with the less battery, with the less energy, the vehicle drives a little bit longer. So that is a way, kind of sustainability equals with respect to this kind of technology. So that's why always when we say placing the child, that term here is, it is not just marketing, it means the leading the way. We are rethinking the entire fundamentals as a system as a whole. So that is the point over here. Okay. So one of the key reasons we have been able to lead the EV technology in Lucid, because we make most of our critical systems in-house. So nothing will buy from any of our external vendors like China or whatever the other OEMs will do, because everything is in-house technology. I will highlight few of the things. One of the things is the battery pack, which is very lightweight and it is thermally managed, because the heat control is very important with respect to battery pack. And of course, the next one is the inverter, which is the brain that converts the battery DC to motor AC with the incredible efficiency. And of course, we have a motor, which is world's smallest motor in the EV segment. Comparability, if you can name it, it can be a Tesla or whatever the EV is out today in the market. Ours is a compact motor, which definitely, kind of produce the maximum energy per kilogram. So that is one of the key technology which we have in-house. That technology is already recognized by external OEMs as well. They're ready to work with us in that sense. And of course, the software part, people will talk about the software, it's just for the infotainment, correct? But it is not. The software is another nerve system for our entire technology in terms of controlling the energy flow or thermal management, even sometimes the driving experience, because the chassis teams needs to do a lot with the software today. As we speak today in Lucid, most of our vehicle dynamics, it's controlled through the software. And last but not least is our Wonder Box, which is kind of bi-directional charging system that supports fast charging. The same times we can supply the power from vehicle to grid capabilities. So these are our kind of flagship in-house technologies, which as leading help us to lead in this space. So of course, kind of these are the key critical awards which Lucid got. Definitely, kind of the external recognition also it matters, correct? For us, our car owns numerous awards like with respect to efficiency, design, and performance. These are all done by the legit independent reviewers. So definitely, kind of we have one of the best product. So the key takeaway here is, with respect to our subject, system thinking and sustainability is not just as a buzzword. That's what I earlier said. They translate into the measurable recognition. So these are the things specifically, kind of proves we are in the right track. I quickly talk about Lucid first before jumping to the subject. Bear with me. It is not just a marketing. It is, you need to understand what we do. Then we can, I talk about the concept or whatever the, system thinking or model-based systems engineering definitely how helped to shape this entire product line. So that is the main point over here. Okay. So let's talk about our product lineup. So we have started with the Lucid Air, which is a luxury sedan focused on long range. And now after that, we just shifted our gear to the Sapphire model, which is a performance variant, and to the customers who loves the speed and acceleration. And now we are in the Gravity, which is our flagship SUV that balances both range and performance as well as versatility. Okay, each of this product targets different customer needs, but the catch is here is if you do more variants, definitely we have to do more complexity. That's the key here. Okay. Maybe I'll give one analogy. Think about it. A sedan is aerodynamically easier because than SUV, but the SUV is very much challenged in terms of more space we need to provide the same time, which increases the weight of the vehicle, and definitely there are a lot of features. So that ripples through the aerodynamics, or battery requirements, or software tuning, and thermal management. So we have to balance all these things. Okay. So definitely the system thinking is only what allows us to manage all of this. Without that, definitely, kind of you need to design each vehicle almost from the scratch. So it will lead to duplicate effort and increasing error. So the key takeaway here is system thinking is definitely is a key for this kind of complexity and versatility. So that is the message here. Okay. So okay. So till the marketing is over, coming to the actual business. Okay. What is the problem? Every new feature, whether it's a battery variant or software mode or supplier component, adds layers of interaction. Correct? Alone, all of these, each one make a lot of sense, but if you put together, it becomes overwhelming for our product. Okay. The key issue here is the traditional engineering methods looks components is in isolation, like mechanical focus on the parts, electrical focus on the circuits, software focusing mainly on the code. But the real world, this kind of silos, different silos, does not work in practical way. Correct? So that's why the system thinking is not optional for anymore, especially for EV industry. It is the only way to manage this complexity and ensures the sustainability. Okay, the same thing I'm going to cover on the next kind of slide, which is about automotive trends. Correct? Just bear with me. I have. Okay, so I want to talk about okay, let's zoom out and look what is happening around us. Correct? Mobility itself is going through lot of revolution. Correct? Sometimes it is something which we used to call as a re-evolution. Correct? Why? Because it is not just making cars anymore. We are redefining the way that mobility is going towards the future. How the people move, how they connect, and how the consumes the mobility, correct? Traditional, in our older days, we just buy a car and we kind of after that it is just it's maintained regular maintenance, correct? But today the mobility, it is something like ecosystem, especially in Bay Area or Texas or so. You might have heard the news, correct? Already we have this Waymo, and Google as it's Google's one is a Waymo, and Amazon as a Zoox, and Tesla as a robo taxi. Even we do have our next ride sharing program along with Uber. So it's more on subscription models and connected service and over there updates. And also it's all needs to be integrated with the cities, correct? Each city has its own regulation, so everything needs to work together. So the mobility comes today, especially on the EV space. It's not about evolution, it is really a revolution for us. Okay, what that means, the value is no longer just a hardware product, just not a car, correct? So we need to think about the data and the connectivity and the services. Just it supports those entire ride sharing ecosystem. So in that case, definitely customer will not just only ask while buying these EV cars. So definitely we need to kind of think about how this particular machine integrates with their lifestyle, and how they can able to updates like mobile today. If you buy, but every keep on, there are a lot of updates, how easily they can able to get those updates, and how this is more sustainable in long run in a practical way. So all those entire things, while designing the EV, we have to think and keep it in our mind, correct? So what is the key problem from traditional versus the systems thinking? Let's be honest, correct here. Most of the traditional organization, especially in the engineering world, it is the data are structured in silos. So mechanical engineer is only work in one department, and electrical, it's like our college, correct? Mechanical engineering and electrical engineering and software and definitely the manufacturing. So everything is in the silos, but each each of this group actually optimize their own piece of puzzle. But if you take mechanical, they are mostly focused on their weight and design optimization, etc., etc. Electrical, and everyone's they're working silos. The main problem here is when it integrates together, that's where the complexity starts. So there is together it may not work in perfect world. So what we say is in our CEO always says, when we work, it's definitely it's a local win, but it is a global failure. So that's what our CEO always encourage us to do more on system thinking, work in collaboration, and do these systems, model-based system engineering rather than the file-based. So that is the main concept here. Okay. So for example, I give you example which practically we had. Okay. So one of our motor team started changing the winding for the great performance. But what happened, that particular change is drastically increase the heat load. Then because they worked in silos, that is not well informed to our thermal team. So they have done in certain calculation, but because of that, the battery got overheating. So again, now battery teams came into the picture, they have to solve that same puzzle. So in top of that, the software is trying to control the heat, the overall performance of the vehicle, it's getting dropped. So suddenly the actual local win, it becomes a global failure as a system as a whole, as a car. So that's what kind of the real problem in any of the traditional automotive. And at least as a EV startup, we have that opportunity to correct fast because we are started with scratch, and we are producing the brand new idea in terms of electrical vehicle and sustainability, and we know this puzzle very early. So we are trying to work in the system thinking approach, which helps us to lot to handle this kind of complexity. Okay. So what is the kind of main cost or we have to pay off if we are not handled these specific things in a proper way is cost of correction. In the engineering, there is a golden rule, correct? The later you find the problem, the more expensive it is to fix. So if you catch a design flaw in the concept stage, for example, if you I'm starting a brand new concept design, so at that time, if I find any problems, it is just a discussion, so it's easy to correct. There is no cost. But at the same time, the same bug, if it is identified, my design is frozen, so it's went to the prototype build or for all the validation side. So definitely it is a little bit more cost because already I brought the hardware and I sent the cost. I released my purchase order to the supplier to cut the tool, which is a huge amount. So all those things definitely to correct, I have to spend more for the new design, new tool, and etc. and the prototype. But if the same thing which we find later in the game in the production, definitely it is a disaster because it is already the vehicle is the customer end, so if we find the problem we lose our reputation, and sometimes it will kind of create the brand damage as well. So it is like catching the typo, correct? So if I'm typing something, if something went wrong, if I can able to easily correct it as soon as I noticed it in very early. But if you started printing with the same typo as 10,000 books, of course, everything needs to be scrapped. The similar way in our product development, if you catch in the production, all the inventory, all the money which we spend, everything needs to be thrown away, and we have to spend more in order to correct those mistakes, and which we have to pay a lot of money. Okay, so that is the kind of cost of correction. If you find or if you are not having the system thinking approach in very early, you have to pay. Okay, so what is system thinking? Let's go with the basics, correct? The system thinking is about seeing as a whole. It is not just a part. Okay, instead of asking does my component work? Normally, in our entire company, we ask how does how this particular component interacts with other component, like how this battery interacts with the motor, how this motor and battery together is controlled by the software. So we have to think as a whole. So it is pretty much kind of it's a mindset shift, because most of our engineers comes from the traditional automotive. They have worked in very silos because it's a big company. There is a lot of teams, individual. They'll focus on their own lens. But as a startup and small organization, we are building our company from the ground up. So everyone needs to do everything. Everyone needs to understand everything, each other's elements, so we can able to work as a team, as well as in a collaborative manner. The main key here is the system thinking approach is changes that mindset from working in silos to a collaborative way. Okay, so whatever the system thinking, it is not just any tool or something. It is not just a process also, it is a mindset. So when you adapt it, definitely kind of you really discover a lot of unknowns very early, and you understand the power of integration. So that's the main key. So this is very difficult earlier for us, because everyone comes into the different background and different mindset to bring everything together. There are a lot of investment we have to spend on the OCMs. OCM is nothing but organizational change management mindset. So that is a key. Okay. Because currently I'm leading this MBSc in Lucid, I know very well how much struggle which I faced and still I'm facing in order to achieve these entire systems engineering concepts into the reality. I can definitely kind of I'm privileged to talk about and share my experience with all of you guys again. Okay, now let's connect this mindset into a practice, correct? Like a model-based systems engineering or MBSc. So everyone talks about the MBSc. Some people MBSc means is just managing the requirements. It is not. It is MBSc is a practice which will enhance the systems thinking and model-based engineering and sustainability into a reality. So this is the very key, and this is a practical kind of deliverable for systems thinking approach. Okay. If you talk about the traditional way, the system engineering was mostly on the document based. The requirements created in the words and drawings are kind of in the CAD, the entire design documents in the CAD, all the test plans in the Excels, and the entire collaboration happens through emails. That's what when we started our company, our first product Air, we had the same concept. So all the requirements in different silos. So each of the systems engineering, they're creating their own requirements and keeping it on their preferred tools. Probably in the Word document, something in the Confluence, something in the share file, etc., etc. And based on that, our engineering team designs the product. So there are disconnects. Sometimes the requirement changes. The design team is not properly communicated or aware about those requirements, or vice versa. There are some designs pushes the requirements which connects to the some other need. For example, as I mentioned, traditional, the battery changes from the design or cell chemistry, something which drives to the software team, which may not be recorded into the requirement document, because the same requirement document will go to the software team as well. So it's all kind of file based disconnected way. MBSE replaces all these with models. So instead of a document scattered across the team, we build the system model. So we use here, there are a lot of tools available. So we use here something called no magic, which is the SysML model. Entire our architecture is defined as a models. It has a requirement model, functional behavior model, and its interfaces and its constraints. By doing this, I can able to completely have that traceability. These requirements connects with this particular design. The same time, the requirements as a connected test cases for the verification and validation, and what are the interfacing component, so which will help us to identify early failures in the form of FMEA, correct? Design failure mode effect analysis. The same times that feeds into our manufacturing, so I can do early manufacturability, something called DFM, design for manufacturability study. So then that feeds into the product failure mode effect analysis. That is mainly on the manufacturing side. What are the potential failures can cause? What is the mitigated needs and all those things? So everything I can able to see in terms of digital models and its traceability. So it is very much kind of helping us. So the system models becomes a single source of truth for mechanical, electrical, and software team, and verification validation. That is very important. So I think the big message here is, as a summary, I would say system thinking is a mindset. The MBSE is a methodology, brings that mindset into the practical approach. Okay. You guys are not overwhelmed with the message, correct? I'm keep on talking. I think it's good, correct, Manoj? Please stop me or raise your hands anywhere if you want to have any more questions or clarification. Okay. But definitely at the end of the session, I'm going to have the QA session. Bear with me because it's a lot more to digest, and I compressed these entire things into close to 20 to 22 slides to give more holistic context. Okay. So just now we have introduced the MBSE to all of you. Let's talk about what actually it enables. Definitely, it enables the innovation. The traditional development often follows a linear approach. We design, then do the prototype, and finally test. Then based on the test feedback, we correct and repeat. Definitely, it slows down the entire product life cycle process. And the most of the time, the problems we are finding out late in the game. After testing, there is issues. Then again, we'll come back to the drawing board. Okay. But this model-based systems engineering, what enables us is to simulate alternatives and kind of definitely we can think about multiple alternatives. If you, for example, if you take performance or cost or sustainable, these three as a parameter, we can kind of do some sort of trade-offs. If I reduce here, but still I can achieve a little bit more here, something like that. I'll give you some example later, correct? And also we always by this MBSE approach, not just I feel this, not opinion based decision. We always make a data which will help us to make a better decision. That's what I'm trying to say here. So I'll give one example. Suppose we want to balance these three competing goals. What is that? We need to kind of on the acceleration and the range or the cost. So if you think about this, all handled by the different team. We have a dedicated team to focus on the range. We have a dedicated team focus on the acceleration, and definitely my finance PD works on the vehicle overall cost. Okay, so all these teams work in silos. Each team they push their limits for their own optimization. Like performance team wants to have more power. The sustainability team wants the vehicle weight needs to be reduced drastically. The same time, the finance team want the lower cost. But if they don't have this holistic picture, definitely it's very difficult. But the model-based engineering, because all those information is available and it's well connected, so I can just tuning this button here and there. I can simulate what exactly happens on each of this parameter. I can find some sweet spot which is best works, and if I compromise acceleration, still I'm able to achieve the sustainability. That means the vehicle weight will be reduced. At the same time, I'm reducing the cost. I can give more range to the customer. So those kind of sweet spot I can able to simulate within this model-based systems engineering environment. Okay. Again, the key takeaway here is it is not just a documentation. It is a decision-making tool which help us to kind of take some sort of action, and we can able to definitely innovate a product more responsibly and the same time sustainability as well. Okay. Okay. One of the most common question here is, do we have to use the same tool to achieve this MBSE? Correct? Most of the time, no, because every team has its own tool, and our main goal here is federate the information into the same form and shape as an output. Whatever the outputs comes from the individual teams, like a mechanical engineer, electrical engineer, and software engineer and manufacturing engineer, they use their own tool, but those outputs connected through the shared model in terms of requirements and interfaces. Okay, so by that we can get this holistic view. So most of our CAD teams definitely uses their CAD modeling software, either ProE, CATIA, or NX, and the electrical and electronics teams use their specialized tool like OrCAD or some sort of specialized tool with respect to E. And the software team mostly use Jira or GitHub, or now lot of plenty of tools, but all of them something in the shape or form, it's connected through the system modeling tool as output to track this entire traceability. Okay, so what is the key takeaway here is still they can work on their specialized tool, because we are not asking them to come into the one single source or one tool. It is mainly we are trying to federate those information to take a better decision. So it's mostly on not forcing in one tool, it's federating the information so we can connect them well, so we can take a better decision. Okay. And the next concept which we talk is about the system thinking approaches. Mainly, I'm going to introduce another very important concept in the systems engineering which we follow is shift left. So what exactly it means in our automotive or in the industry world is, traditionally, all our validation and testing happens late in the process. Once my design is completed and prototypes, in the prototypes, they do the verification and validation. So by that time, the fix is very expensive. So what shift left means is bringing the validation parts very earlier. So how? So instead of spending a single penny with respect to hardware, what we do is we use these models to do the feasibility in the concept stage itself, which is something called advanced engineering. So we do the engineering in advanced way with use of these system thinking and more MBSE tool sets, which will help us to do without making any actual hardware to do the test. We do digitally using this kind of virtual simulation or virtual validation, etc., etc. And of course, we will validate, as I said, the entire requirements within this digital tool, so we can understand if, because each of these requirements is written by multiple different tech specialists specialized on those fields. Because how this requirement cycle will flow is we have the L0. Normally the term is L0, L1, L2, and L3. So like as a system requirement, subsystem requirements, and component requirements. The system requirements is very broader level, which is defined by marketing and few of of course, sometimes that is driven from the customers or the people like you expect something, so we will do some sort of market survey and capture this is the holistic vehicle as a system requirement that decomposes what goes to the software, what goes to the hardware, and what goes to the electrical architecture. Then that further decomposes to what is chassis. This exactly that entire decomposition happens while writing this requirement. No one has this holistic view. Each requirements, it is more seamless. There are conflicts between those requirements, correct? So those kind of information we can able to identify very early in the game, so which will help us to kind of fix in the requirement stage itself. So we are not kind of catching those requirement conflicts in late in the game. So this is one of the kind of main advantage to shift left. Okay. And so now some of you might be wondering, that is sounds reasonably good, but do you think it is heavy, the process wise or methodology or tools wise, it might be too heavy? Of course, kind of it is by looking into at first, looks like it's too much heavy. But we introduced another concept, something called agile methodology. Traditionally, all the traditional approach is more on waterfall. It is more sequential, but we follow along with the systems thinking with more agile, which will help us to do file fast. That means instead of kind of filing in the late, we quickly put this, kind of first we'll define the targets and KPIs, and then we will build the architecture virtually. Sometimes we will not, because it's already created for one product, we can try to reuse the existing models, so that accelerates again. And we do the early validation within those models. Finally, kind of we can compare multiple variants, we can do the trade-offs. So if it's not working, we'll throw out and we started with the next iteration. So agile with system thinking is more kind of easy, and it pays off a lot for us and finding the problems very early. So that is a way the traditional companies takes 4 years to launch a product. Any new age startups, they can come the products very quickly, very faster because of this kind of methodologies and tool sets. So they are, even without spending any money with respect to the hardware build, the virtual validation, we used to call it the digital twin, is helping us a lot to do this early validation, finding the early problem, find early to correct early. Okay, so that is the main thing. Okay. Let's zoom in now on what system engineering really means into the practical. Okay, so these are the different components which I talked. We have requirements, mechanical, electrical, and so on and so forth. System model, it is not just a kind of diagram. It's mainly connects the actual entity to collaborate. For example, the requirements from the stakeholders and the same requirements, it fits to the mechanical and electrical design that I can simulate with the software behavior and all of these entire things. Today, we have that digital model, something we used to call digital thread or digital twin with these MBSE tool sets. Okay. So the formula here is system thinking is not something, it's a mindset. The MBSE, it's a methodology, but puts together, it's definitely, kind of creates the collaborative backbone to interact all these different silos into a single source. So that's where the traceability is produced. Any point in time, any of my engineer goes and click a button, automatically button in the CAD. If I open one of my design component, if I can click and I want to see the navigation, automatically my system will show, hey, what is this connected requirement and what is this connected TFMEA and what is this connected test cases, which revision of the design is connects with which requirement. I have created the new revision. What revision it is, kind of what requirement is given that particular revision and connected change, and which has lot more. So everything is digital thread, which is very much we are trying to connect as much as possible to provide the holistic visibility to take a better decision. So the systems engineering, this MBSE or systems thinking, whatever you call it, it is in the reality, it is something implemented through this MBSE methodology. That is the current trend. Okay, so let's talk about, I think pretty much all of you might have understood end-to-end process, correct? With respect to the entire product life cycle, any company, you have this product vision and target agreement. These are the different golden milestones in the product development. In most of the organization, including Lucid, we still treat development, it's like a relay race, correct? The requirement is once defined, we will throw it into the design. They will do the design, then we'll throw into the manufacturing. Then finally, it goes to the testing, then it goes to the customer, then service, correct? The problem is every of these hands off to kind of create some sort of silos as well as data loss. Okay, by doing this digital thread approach, what exactly it is helping us is everything is connected across these different gates. So we can, kind of the benefit more here is in the concept stage itself, we can see how or we can involve our manufacturing team involved we used to call it a set team. So every stages of these milestones, there is a set simultaneous engineering team which comprises of all of these people will be sitting and giving the sign off. It is not requirement engineers, then it goes to design. So each of these milestones, these set teams, that is another concept which we introduced here, something called simultaneous engineering team, which comprises of all of these people will be part of this each of every decision throughout the product life cycle. Okay, so even the set team is not just a team. Without the data, the team does not make any decision, correct? So these MBSE concepts will help them to give the data point to make those set teams on a better decision. Okay, so that is the main value. So what I'm saying here is the gates, all these gates should not be the walls, it should be the connected doors. That's what I'm trying to explain here, the concept on the MBSE side. So it is every gate, everyone will be informed and involved to take a better decision to move to the next stage. So when it comes to their work, they are very much aware what was that earlier as a team which we took the decision. So they know what is the deliverables. It will be smooth and quick, so they can move to the next stage. Okay. So this is a very complex V model with respect to EV engineering. We try to put it into the simplified way. If you see here, there are a lot of teams involved here, starting from the governance team, and we have MBSC, which is as we definitely kind of spoken a lot in the previous slides, and how the MBSC it connects with various teams and departments and deliverables and etc. etc. Maybe I'll just put it into the simple way. Definitely, this MPSC is very much important, more than any other industry, for electric vehicle engineering. Okay, because the EV is most interdisciplinary product in automotive world, which has hardware in terms of battery, motor, inverters, and definitely we have specialized EE architecture, which has complete harnesses and ECUs and sensors. And of course, everything is both controlled through the software in terms of controls, infotainments, and OTA updates. And definitely all those things together need to have some sort of simulation and validation through virtual twins. And there are a lot of validating environments. We do a lot of bench tests. And of course, kind of there are still we work with a good amount of suppliers on their subsystems like seating. Today, in traditional cars, the seating has very mechanically adjusted. Today in EVs, we have, in the seat itself, we have close to 50 features. Like it should have the massage has 3 modes, and heated seat, ventilated seats with multiple 6-way, 8-way, 12-way adjustments, and etc. etc. The complexity. So everything needs to be connected with controls, electronics, softwares, wiring harness, and ECUs. And all this connects with our safety systems, like the airbags, because the seat also has airbag, and it's really complex. Okay, and finally, before selling this kind of beast to our customers, definitely we need to validate thoroughly. Each of these elements needs to work in picture perfect in the right place at the right time. Correct. So everything needs to be properly, thoroughly validated. We need to have some sort of multiple validation loops. So every time we cannot go back and build the entire vehicle and start validating it. We have to validate as much as possible, virtual iteration. Then we will do the prototype. Finally, that's what our EV's main goal is: how to reduce the cost. We do as much as possible virtual simulations using these kind of techniques, and we produce very less prototypes, so the cost is less, and directly we'll move to the production. So that is the way we can reduce our entire product development life cycle. So in a nutshell, as a summary to remember here is, EV is not just cars with the batteries. It is system of systems. Okay, and the system thinking is the only way to make this product as sustainable. Just take a water a little. Okay, we talk about end of the day, this is a business, correct? Now let's connect this entire concept to the business side, because the system thinking is not just for engineering hobby, correct? So we are not doing for hobby. It is definitely responding the business needs. So most of the time, executives or leaders often ask these 3 things for us, correct? Hey, have you captured all the requirements very clearly, correct? So how can we collaborate, kind of better with our internal as well as external suppliers? So most of the time, it is their classic question is, hey, how we can able to reduce the cost? The value engineering team is keep on bugging each and every team. Hey, this is your cost target. This is your cost target. Please try to reduce it as much as possible, because in the long run, most of the EVs today, whatever the product we deliver, it is not much profitable, because we need to have the volume. The same times, we need to always try to optimize as much as possible to reduce the cost, so we can reduce the cost of the vehicle, and overall that value needs to be cascaded to the market, so we can able to sell more cars. End of the day, it's all business, correct? So systems engineering and MBSE is directly address all those 3, correct? So we can able to capture our stakeholder needs, not in form of as a textual documentation. We capture everything in terms of models. Okay, the same times we have to collaborate with multiple people internal between the teams, and within the teams outside of the company. So it's all I have to collaborate. For example, today Lucid works with three vendors. For our recent rideshare project, we have to Uber is our end customer. We used to we are the integrator, and I have kind of getting from some technologies from Neuro. So all these three parties, I have to Uber defines the high level requirements, and as an integrator, I have to work with my other suppliers to get their components and integrate into vehicle and deliver it to the customer. So I need to handle this kind of people with it's email. It is not the option at all. So we have to have some sort of system which digitally help us to collaborate and interact with them. And finally, based on all their requirement is met, I have to produce the evidence. Hey, Uber, you asked these are the high level requirements. I built the vehicle, I tested the vehicle. So this is my evidence for you, what we have done. So everything is achieved. The sign up is very much important. So we are not just taking a decision based on some sort of opinion or Word document or something. So we have to have some sort of connected logical system to produce those kind of results very efficiently and accurately. Okay. Definitely, the system engineering is not just a technical methodology or whatnot. It's definitely a business enabler. Okay. Okay. So I have to bridge this towards this decarbonization. Correct. Sustainability. End of the day, how to reduce this carbon footprint across the multiple ways. Correct. EV has taken a step forward because that is one of the key. So let's connect sustainability directly to our engineering. Correct. The decarbonization is a journey. Okay, to reduce the carbon emission, and it is not a step-by-step problem. It is a chain of stages. If you see the swim lane, so you have kind of authorities. So it is actually started around 2010. Then kind of every country, they had their target to reduce the carbon footprint by kind of switching to this new age hybrid or complete electrical mobility by 2035. Correct. For that, definitely the vehicles, specifically the automotive sector, is taken an early path to do some sort of research in terms of battery technologies and the engineering and mass production and sales and everything throughout this timeline. And of course, that leads into the kind of infrastructure challenges. So we need to have that kind of infrastructure in terms of charging stations and this, if we are trying to do as an alternative fuel like hydrogen, and all those infrastructure planning is very much needed. And it comes to more connected cars, which needs a lot of apps and kind of that apps comes with this security threat. So the cyber security rules and regulations and everything. Correct. It's a journey. So we are kind of going step by step with a gradual transition. With respect to EV, definitely there are 5 stages. In the product development, we used to care about materials, which is lighter and greener materials to support this decarbonization as much as possible. And of course, the manufacturing, all our manufacturing is green field manufacturing. We started from the scratch. So it's not something we bought some existing manufacturing plant and build our product. So our manufacturing, advanced manufacturing plant 1 and 2, which is there in Arizona, as well as Kingdom of Saudi Arabia, both we planned reducing waste as much as possible. We use a lot of renewable energy, and we control the emissions as drastically as possible in the plants as well. And of course, logistics is side also. We have done a lot of co-located logistics operations in our manufacturing. So it reduces shorter transport in terms of emission perspective. And of course, while using the vehicle for our customers, we had put a lot of effort to increase. One of the example is charging time, correct? So we reduced the charging time, so customer may not spend more time. So which some form of savings there. And of course, we given a lot of vehicle efficiency. So one of our main selling point, Lucid Air, is it is 512-mile run per charge. Okay, so from I'm in San Francisco to Los Angeles, so I can do one stretch without stopping anywhere. So that is the kind of range with less battery and less power and a smaller motor we could able to achieve with good aerodynamics, which I thought about, correct? And definitely after the fact, end of life, whatever the product which we made, it should be recyclable. So these are the key things, especially with respect to decarbonization in Lucid. We are taking care. And okay. So let's talk about kind of it's a 15 minute topic, but I due to the time constraint, I have kind of try to reduce it or simplify it as much as possible. So how do we make sustainable in the practical and engineering, correct? By linking directly into our system models is one of the things which we talk, and also the sustainability, definitely we don't treat as an afterthought. We treat is another requirement. Whenever we create any requirement or in the product development early stage, we'll keep sustainability is one of the key requirement, like other performance requirement or safety or cost. Okay, so for example, when we model a battery pack, is one of the example, is definitely we include the cell chemistry impact and manufacturing steps of the battery cells, as well as what is the thermal management, which will drastically adds a value in the battery pack. So that will in turn gives a longer range. Of course, how much kind of that entire pack is recyclable, and what are the potentials. The same way for motors as well, we consider the efficiency and the material which we source. Of course, kind of energy use across as a system, as a car. Okay, well, how much energy is consuming for overall end of the life cycle. So that's where the range, performance, and everything is matters. With a smaller battery pack, I will give one example. Okay, if I try to reduce 5 kg of weight in a vehicle, it seems very small, correct? So always my sustainability team is always fighting or giving the target to the engineers is as much as possible we have to reduce the weight. So, but over the lifetime of the car, definitely it reduces the energy consumption very significantly, and also the recycle is very much easy, and this small change definitely uh, helps us to do multiple sustainability events. Okay, so for the key takeaway here is sustainability is not just a checkbox for us; it is engineered in every decision throughout the systems thinking. Okay. Okay, I think we are kind of conclusion stage. I think I have covered a lot through this, kind of more than our session. And what we have done is, what does the sustainability means in terms of engineering, and it's about creating the system that last, adapt, and deliver the value in very responsible way. So, and something which we talked about, what is system thinking? Definitely, kind of. It's a mindset, correct? The system thinking is a mindset. It means looking beyond the silos, seeing the connections, and asking, if I change X, what is going to impact on Y and Z, etc., etc. And also we explored the model-based systems engineering. So that will turn the mindset into the practical way in our day-to-day practice. Definitely, it is replaces our entire documentations with integrated models. So the models, we capture the requirements, we do the behavior analysis, interfaces, we can clearly visually understand. And of course, by doing that, I can able to play around different Hello. 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 Can you guys hear me?
Yes, sir.
Hopefully you can hear me, correct? So audio is fine, correct? I was seeing some mute.
No, it is audible. You can continue.
So previously you can able to hear, correct? Whatever I was explaining to you guys, correct?
Yes, you are in conclusion part. Praveen, sir.
Yes, can you hear me?
Yeah. Please.
Hey, Manoj, kind of throughout the session, you had the audio, correct?
Yeah. We had idea. Is there any problem?
No. I
No
thought
participants.
I was seeing in my kind of Zoom, it was on mute. So I'm just wondered, it is throughout the session slides you can able to hear me, correct? Whatever I explained you, correct?
Yeah. We have seen everything.
Okay. Thank you. Kind of this is my end of the session. I'm kind of glad to be part of this. You have any questions with respect to systems thinking or MBSC? I'm definitely here to answer you guys.
The participants, the forum is open to you. If you have any queries and questions regarding this session, you please figure out. You can switch on your mic and you can ask the questions if you have. Otherwise, you can share in the chat box also. Participants, any queries from your side? If not, you can close the session. No queries? Mr. Praveen, I hope the thing is very clear. The presentation is very clear, and definitely you have learned a lot regarding the EV, the uh, things what are all happening in the industry side, and other kind of stuffs we really learned. It's a very new kind of thing to us, and I thank you so much for spending your valuable time. Thus, I can understand that you are in your office. Am I right, Praveen?
Yeah. I mean, I came early today for this.
Yeah.
So it's 8:30.
For the sake of the presentation, you came early to the office, and but you have spent a lot. I can see your presentation. You have spent a lot of time to make it clear because a lot of things are happening inside the industry. I can understand when we are speaking personally, you discuss a lot regarding this, and I can understand you have made this presentation, clear presentation, so that the audience can easily understand the things which are all happening in the EV industry specifically in terms
Yes,
of
thank you,
engineering, in
Manoj.
terms of sustainability, and in terms of all other kind of managerial issues that are all happening inside the industry. Thank you so much, Mr. Praveen. On behalf of the Department of Mechanical Engineering, Adi Sungara Deemed University, once again, we thank you for your acceptance, and spending your valuable time in between your busy schedule for the sake of our audience, for our participants. Thank you so much.
No worries. Thank you, Manoj. Thank you, all of you, for that valuable time. It's 1.5 hours really, we need to value. So I hope I have, kind of took all of your time in a meaningful way, and I given some insights based on my experience. Thank you.
Yeah, basically, most of us are belonging to academics, but when we have people like you on board, then definitely we are having a different kind of perspective on view regarding what is going on in the industry in terms of the emerging areas like in the EV industries and all. Yeah, once again, thank you for your kind presence over here.
Thank you, Manoj. Thank you. Thank you all.
Thank you.